It's a pleasure to be here. My name is Bob Beler. I have my associate David Marshall with me here today, and we're excited to be part again of Angel Bee. I just want to make a general statement before moving forward in our presentation. One of our key verticals is the government public sector. We're aware that the pandemic has spurred, the acceleration of digital innovation across that sector, presenting government leaders with new opportunities, we'll call it, to use data and technology, and to build trust and agility and resilience in these institutions. Our goal today is to discuss those efficiencies and consistencies and quality of service, or the digital, we'll call it, customer experience and optimization with you. So David, if you will, next slide, please. So a little bit who we are. We are a global company. We're listed on the NASDAQ. We have a very strong balance sheet. I'm in charge of the enterprise group for North America and Canada, and that includes everything except our CSPs, which is our carrier service providers. That is where we started about 25 years ago, and we have over 1,000 enterprises. Next slide. Here's just a glimpse of our, we'll call it top four that I put together and threw some names in there. Of course, there are more, so you can't fit everybody on the slide, but I wanted to show that we have a very strong presence, not only in the educational space, but also government. Next slide. So as we dive into our new norm, and I say that with a smile, the digital experience is key for public engagement. It's that assurity that you can provide of how do you take your mission critical applications and make sure, not only from a visibility and monitoring standpoint internally, but from a control standpoint, as Ron noted that Rosa before mentioned, how do you make sure that that's happening every day, regardless of what's going on in your network? And this is kind of where we play. We also play in the hybrid cloud, and you'll see that. I don't want to take away David's thunder, but there's a number of them. I'll call it, we're more like Switzerland. It really doesn't matter to us, but we can add tremendous value from that standpoint among multiple data centers, because that is our space. And last but not least, today, I would tell you there's been a significant increase in attacks that have surfaced. As an example, just doing some number crunching, we're estimating more than 27% more year to date compared to last year to this year regarding DDoS attacks. And so more of our customers are adding this protection to our platform. So we have a number of security features that can be added. And this will protect the, of course, business reputation by minimizing network downtime by these attacks. And David will show you a number of reports that we utilize that can show you, length of time, how many attacks, when it happened, and of course we mitigate those on top of it. Next slide. Just a quick overview of kind of, where we play. There are three platforms that we have, starting with our low end on the ACG, and we basically size these capacities of our solution based on bandwidth allocation. And so we see all traffic inbound and outbound. So our ACG starts at a very low end of 500 MIPS, and we scale all the way up into the terabytes, as you can imagine. So again, started in that carrier space. So, we can put multiple units in there that can handle the highest bandwidth levels and have, hundreds of thousands of policies, partitions that we can provide to our customer base. We can extrapolate the hardware and just do a VMware install, right? And Red Hat. So it's not an issue if somebody wants to install our solution as a software only within their environment. We're quite capable. And then you get a list, as I called it, as Switzerland, of who we play with in the cloud space as far as our solution to help organizations in a hybrid model. Next slide. And this is just a typical diagram that we threw together for discussion today, kind of from what we're seeing. Of course, there's a lot more to someone's network, but it seems like a number of companies want to save and have implemented SD-WAN, you can kind of see where the Allot box would sit. Normally we're between the core router and the switch, even though we can be implemented in other areas of an organization. And then you can see that, you know, we're going to recognize all the different server protocols because there's thousands of protocols that we dynamically recognize. And then, of course, we already have the science and thresholds of kind of what bandwidth those applications take. But more importantly, within this diagram, you can see that as citizens or employees, whether it's internal or external or virtual, we can actually create policies per application, regardless if it's mission critical, or even more important, sometimes what we're seeing is non-mission critical in controlling those. Next slide. So I'm going to pass the baton pretty soon to David, okay, after this. We noticed that most government organizations that we've dealt with are moving from that distributed architecture more into a consolidated approach, right? I listed their PS, by the way, I apologize, that stands for Packet Shaper Replacement. In 2020, roughly March, you could Google it, Broadcom basically did a public announcement after they bought out, you know, Symantec, who bought out Blue Coat, that they recommended Allot as the replacement organization for their Packet Shaper customers. So those of you who are listening who are familiar with that, we've already migrated hundreds of accounts over to our platform. And most of the customers that we've talked to are amazed with, I'll call it the robustness of our solution in comparison with not only how far we scale, but the multitude of policies and partitions that we provide to them in the same similar bandwidth that they were used to. We also do multi-tenancy, which can be very important to a number of government or public sector companies, because you're really acting more like an MSP, in my opinion, to a lot of the organizations. And so with that, I'm going to pass this over. I know David's going to get into a couple of use cases and dive into those examples technically for you. So David, the floor is yours. David, I think you got to undo the mic button.
Okay, can you hear me now?
We do. There you go.
All right, that's a lot great. So thanks, guys. Thanks for your time. And I know it's getting late in the day, so I want to make sure we cover everything in a lot of time we have. But I want to go through one case in general, and this is a shift that we see from, I guess, in one regional or national government, in this case, from branch data centers into a cloud architecture. And this could be either a private cloud, or in this case, could go in transition into a MEC or a AWS or Azure cloud as well. And so what we see is a shift from that branch entities that are shaping the remote sites. They have separate management for each entity. They have complicated policies, and they have zero consistency. So a remote person or a remote user could log in or try to log in VPN into each government entity, and they're going to get a different level of experience, a different digital experience, depending on which entity they're logging into. And so what we've done, or what we've been asked to do, is to shift that into more of a cloud architecture. And that is shifting from those branch governments down into a centralized location or cloud architecture, and then out into the MEC. And what that does is bring in the ease of use, a unified management, scalable into the terabytes that we've been in place here, and then give a multi-tenant access to each department that used to have access to their system, but now we're going to give them visibility. We're going to give them some level of access and control of their network. And so what we've been asked to do in this case is to consolidate many data centers from having separate policy and systems to a single or several smaller, or I guess larger databases or larger data centers. scale that into the terabytes, provide granular visibility, policy management, traffic monitoring, some traffic steering. There's some third-party applications where we need to either do TCP optimization or some sort of WAF implementation. And then, of course, provide the QoE on those critical applications versus recreational activities. And then that's going to give us some congestion control. That's going to give us consistent quality of service across all branches. It's going to give us the ability to do service chaining traffic to third parties in a centralized, easy location at layer 2. And then obviously deliver mission critical application access. And so we were deployed, and here are some of the requirements we were asked to do. We wanted to prevent congestion into those security zones, into that VPN network. Now the paradigm is moved to at home or work from home locations. They would VPN into a government location, and then that would be sent out to, they would be able to get to their cloud access or to their government services. They wanted to do this in a minimal impact to their web conferencing. They wanted to have detailed analytics of the transition from that branch to a centralized location. They also wanted to have wide reporting and analytics, and then have access to that third-party TCP optimization, or in this case, our Allot TCP optimization platform. And so what we found was, before I show the next slide, I want to just, the paradigm of going into a work from home scenario is that people forget where they are. And when they're logging into their VPN sessions, they're at home and they're comfortable, and there's some recreational traffic that may happen as they're on their VPN, right? They forget where they are, and they forget the sites that they're visiting and access. And so what we're doing here is trying to protect them from either embarrassment or policy, and being able to limit the access to those while they're on that VPN, and save our VPN concentrators as that goes through. And so this is not actually the traffic. I'm not actually allowed to show you the traffic that goes through those VPNs, but this is a very close representation of the traffic that we've seen. And so if you can see here, there's a lot of traffic to, obviously the Amazon cloud, Azure, the normal cloud products that you're going to go to, that they're going to access. There's also some recreational traffic here that you're seeing as well. Netflix, some of those streaming video that may or may not be allowed for policy. And in this case, this government would not like this to be allowed, or at least monitor, or at least manage those. And so what do we need to do? In this case, they want to shape and block peer-to-peer access to some recreational traffic. They want to prioritize critical applications over some services that may be recreational. They finally want to integrate a AAA and be able to enumerate on a per user basis that traffic. And then consequently, by enabling on a per user basis, be able to start managing that ABR type traffic, or adaptive bitrate type traffic streaming that is indicative of web conferencing. And so to do that, you need a multi-tenant portal. You need to be able to configure that. Here, you're able to log in to our site, and this is a dynamic login. This is going to give you an HTML server that you're logging into. Each department's going to be able to get their own dashboard. They're going to be able to control their own policies, be able to create their own reporting. You're able to white label. In this case, I didn't put the actual name of the government entity that's using it, but here it could be ports, it could be anything that you would like. The multi-tenant service portal could give you access to insert rules based on a condition and action. Very simple, easy to configure. In this case here, I'm blocking Netflix traffic by dropping it. You're able to in this case, block cryptocurrency and drop that traffic in a very easy to use way, and be able to give you customized dashboards. So at not just the department level, but at a national level, we're able to give them access to usage and QoE trends, being able to set up network learning on network anomalies, not just in thresholds, but outliers, you know, those things like X standard, the anomaly at X standard deviations from the moving average, that kind of thing, and be able to modify those levers. Being able to drill down into the actual application. In this case here, we're showing Skype information. Being able to show network latency reports, being able to go into not only the application group, but the actual application itself. In this case, you have YouTube, but we're able to enumerate the type of application or even create a specific application for the customer, in this case, government applications and services. And then we can give them total volume, drop packet rates, RTT, and then do that in real time, as well as give them a filter, not only based on the site, but also the different policies, the different layers of policies within those. We're also able to give automatic QoE, or quality protection rule engine. This is a closed loop type of policy. Here we're able to set conditions based on RTT. So here I've created a condition based on RTT is greater than a certain amount. We can create an action based on that to limit either peer-to-peer or even Google Play in this case, or it could be Google Classroom, depending on the application. It could also be an application that you create here. And then simplified configuration and serviceability of traffic. And so since we're at that layer 2, we're able to provide that TCP optimization, so service chain traffic at layer 2. So usually this is done by PBR or policy-based routing or through some sort of expensive load balancer. We're able, and it's usually done at layer 4. And then it's not necessarily subscriber aware. What we can do is service chain traffic to a TCP optimization or a content inspection type of service at the user level. So at application level and user level, and pass that traffic back through the core network out to the internet. And this can be done at any type of third-party application, either TCP optimization, content inspection, a WAF, in this case, our product, or caching, a SIEM, law enforcement, or any other third-party device or application. And that's called service chaining, and not only just one or two, but we can chain that traffic through 1, 2, 3 different services. And by doing that, we're able to provide a very good, efficient network. We're able to prioritize traffic in the highest quality of experience. We're able to give detailed and very good analytics in SLA metrics. We're able to give a multi-tenant portal to those different departments, give them access to the reporting and even control of their different networks, and only access to their networks. And then multi-tiered QoS, or quality of assurance, to differentiate between different service models and congestion states. This is all done in a carrier-proven platform. We are in most tier 1 platforms in the United States as well as in Europe. And all of our analytics that I've shown today can also be done in a data source configuration where it can be uploaded to the cloud.